Hello, we are working on lesson 6.9, relationships with meaning. So we looked at some of those relationships between sides of right triangles last class, and now we're going to dive into trigonometry with sine, cosine, and tangent. So our part one, this is in two parts, this lecture. Part one here says use the information from the given triangle to write the following trigonometric ratios. So here's where we have sine, cosine, and tangent. And I know that, yes, it looks like sin, cos, and tan. However, every time we speak about sine, cosine, and tangent, we speak about them in that way with their full names. So sine is always, SIN is the abbreviation for sine. COS is the abbreviation for cosine, and TAN is the abbreviation for tangent, but we always refer to them with their full names. So now let's talk about this notation a little bit. Sine A. What that means is we talked last lesson a little bit about reference angles. When we have A here, that means that angle A is our reference angle. Okay, so then when we talk about our sides like opposite and adjacent, we know which ones we're discussing. Okay, so I'm going to do these first three with you, and then I want you to pause the video and give yourself a go on the second three using the other reference angle of B, and then we'll move on from there. So these first three, sine of A, sine is a ratio that is always the same. So anytime you see sine of A, it's always opposite over hypotenuse. So sine of A, we're looking at the opposite side, the side that does not touch that angle, and the hypotenuse, which is always the longest side. So that is 6 over 10, which could be reduced to 3/5. All right. Now we're looking at cosine, and cosine is also always going to be the same ratio of sides, adjacent over hypotenuse. So now we're looking at the side that does touch the angle, 8, and we're going to put that over the hypotenuse of 10, which also reduces in this case to 4/5. And finally, lastly, we have the opposite side over the adjacent side. So we're going to look at both that side and this side right here, which will be 6 over 8 or 3 over 4. So take this opportunity now to go ahead and pause the video and try looking at sine, cosine, and tangent in reference to angle B. Hopefully you've had an opportunity to go ahead and look at those angles in reference to angle B, or those ratios in reference to angle B. So I'm going to do them with you really quickly as well and kind of explain. So sine of angle B is going to be the opposite side over the hypotenuse. So it will be 8 over 10 or reduced to 4/5. Cosine then will be the adjacent side, the side that does touch the angle, over the hypotenuse. So 6 over 10 or reduced to 3/5. There's a 5. And tangent is going to actually be the opposite over the adjacent sides. So it will be 8 over 6 or 4/3. So there you have it. All right, now you're going to get the chance to do the same thing for this triangle, and I'm going to give you an opportunity to pause it, and then I'm just going to put them up here in the next scene so that you can check your work and see if you did it correctly as well. All right, you can check your work to see if you got that all correct. Just using those same ratios of opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. All right, we are now going to have a look at question number 3. Use the information above to write observations you notice about the relationships between trigonometric ratios of the two different reference angles of these right triangles. So go ahead, pause the video, write some observations, and we'll reconvene in a moment and talk about it. Well, hopefully you were observing that these are really just inverses of one another, right? So cosine and sine, as we are changing our reference angle, we are just changing where those sit. See how they swap around here and here when we're looking at our different reference angle? So there's that, and then our tangents are just a reciprocal of one another. All right, so that's what you can say there in number 3. And then fourthly, do you think these observations will always hold true? Why or why not? And we can say yes, they should always hold true, since you're really just changing your reference angle. All right, that does it for part 1. Go ahead and check out part 2 in just a moment.